Good morning students, this is Junita Mukherjee from Mrs. Public School. We are going to start the left out part of this particular chapter, magnetic effect of electric currents. So magnetic effect of electric current, two things are there. There is electrical generator and this one is domestical electric circuit. Domestical electrical circuit. So here we have electrical generators, as I have told you about the motors. One thing I have made you told wrong, that is in the case of electrical motors, if this particular arm is moving in the anti-clockwise direction, I told you about this side, but it should be moving in this particular manner. In the case of electrical generator, it will move in the direction of the clockwise, and in the case of electric motors, it will move in the case in the anti-clockwise manner. It is based on the basis of phenomenon of electromagnetic induction, as I have told you what is electromagnetic induction is, and I have told you about this electromagnetic induction by taking two coils and taking the solenoid. Okay, so electrical generators, I will tell you how it is moving. These are the two um, magnets we have taken, and this is the split ring V1 and V2, and this is the split ring R1 and R2. Then this V1 and V2 are the two brushes. It moves from this particular side, means from A, B, C, D. A, B, C, D will move like this, okay, and then move like this, and then move like this, and then again move like this, okay. It will go in the clockwise direction. And what happens to this particular topic or you can say the brushes, is that the electric generator consists rotating rectangular coil, that is ABCD, placed between the two poles of the permanent magnet. The two ends of these coils are connected with the two rings R1 and R2, and the inner side of the rings are made insulated. The two conducting stationary brushes V1 and V2 are kept pressed separately on the ring R1 and R2 respectively. The two rings R1 and R2 are internally attached to an axial. The axial may be mechanically rotated from the outside to rotate the coil inside the magnetic field. Outer end of the two brushes are connected with the galvanometer to show the flow of the current in the given electrical circuit. So whenever this particular this ring is being rotated, what happens? Galvanometer is showing the deflection. This means that the current is being generated in this particular generator, basically because it is used to generate more and more amount of current. So proper large number of turns and coils is being used for this particular electric current to be generated, and by applying the Fleming's reference rule, induced currents are set up in the arm along the direction AB and CD. Thus an induced current flow in the direction ABCD. If there are a number of turns in the coil, the current generated in each turn is added to the given a large number of current through the coil itself. This means that the current in an external flow flows from B2 to B1. After half a rotation, the arm starts moving up and AB moving down. As a result, the direction of the induced current is both in the arm changes, give rise to the net induced current in the direction BCBA. And the current in an external circuit now flows from B1 to B2. Thus, after every rotation, the polarity of the current in the respective arm will change, and thus such a current will change the direction after equal interval of time, and thus an alternating current abbreviated at AC. This device is generated as AC generator. It's called the IC generator. To get direct current DC, which does not change its direction with time, a splittering type commutator must be used. With this arrangement, one brush is all at times in contact and with the arm moving up in the field, while the other in contact with the arm moving downward. We have seen the working of the split ring commutator in a case of an electrical motor. So thus an unidirectional current is produced, and the generator is thus called the DC generator. The difference between the direct and the alternating current is that the direct current always flows in one direction, whereas alternating current reverses its direction periodically. Most power stations constructed these days produced AC. In India, AC changes direction after every 1 by 100 seconds. That is, the frequency of the AC is 50 hertz, and the most important advantage of AC over DC is that the electric power can be transmitted over long distances without much loss of energy. So this is how the electric generator is being explained to this particular explained by this particular diagram. Now we will come to this particular DCA. This is what we have, the earth wire. This is green in color. Okay, this is in green color. This live wire is there. Live wire is the wire where it is red in color or orange in color. Okay, and neutral wire is black in color. So the live wire where the current goes on. Okay, so this particular station, from the station, these three things are being given to the electrical board, fuse itself. Okay, then it is coming to the electrical meter where the meter is there. Okay, in our houses the meter is there. Then the meter is connected with this particular type of distribution box containing the main switch, fuses for each case, where you can look in the upper portion of your upper top portion of your house, and the entrance gate of your house. There is a meter where the fuse are connected with each other. After this, it is connected with that of the supplies, that is fan, TV, refrigerator and all. These switches are given to you to operate this thing. So this is how this particular meter works, and it has been told in this particular meter that on 15 ampere current rating for appliance with the high power rating geyser, that is cooler, etc., will be a 15 ampere, and 5 meter ampere will be 5 ampere will for bulb, fan, etc. It has been given to you in this particular circuit, and we are giving the potential difference between the two is 220 volts we are given, and for the household use, and we have the electric fuse, which is an important component of the domestic circuit. We have already studied in the principle and the working of the fuse in the previous chapter. The fuse is a circuit prevents damage to the appliances and the current due to overloading. Overloading can occur when the live wire and the neutral wire come in contact with direct contact, occurs in the insulation of wire to is damaged, or there is a fault in the appliance. In such case, the current abruptly increases and they cause a short circuit. The use of the electric fuels presents the electric circuit and the appliances for a possible damage by stopping the flow of unduly high electric current, and the joule heating can take place in the fuse melt and it breaks the electric current circuit, and the overload is being caused due to the accidental hike in the supply of the voltage. Sometimes overloading is caused by connecting too many appliances in the single socket. So never use too many sockets in a one particular socket and single socket, and overloading can be accidentally happen with the voltage. Abruptly the voltage, if it is supplied, it can happen, and it can melt the fuse. Then there is short circuiting is there. One more thing which I want to tell you, that these are connected in parallels, not in series, because if they are connected in series, if one circuit will be cancelled, the other also will be going to cancel, but for such reasons itself is connected in parallel, not in series. So this particular topic is being finished here, and I hope so this particular topic is being understood by you. So looking forward for your question answers of the chapter in the next session. Till then, take care and study well. Thank you.